Hi Dorian, it's Rachel. Here's how to do the problem that you asked about, number 8. The first thing to do is remember what we did in class, and this is what it looked like when we did this problem in class. The structures had the proton on the most electronegative element, and so uh, when you looked at those three example structures and were asked to do the same thing as what you're asked to do in number 8, it was fairly apparent that um, the proton that would be donated as the when these acted like an acid um, was the one that's bonded directly to the electronegative element, to the oxygen in each case. But in order to actually argue um, the order of acidity, where this alcohol is the least acidic and the one right next to it is the most acidic, you have to draw the conjugate base. And so here are the conjugate bases of those three structures. With that proton, it's been removed by some base, which isn't shown. And so you need to use these different aspects of structure to say, well, look, this structure is more stable than this one is because you can draw a resonance structure. And this structure is even more stable than this one or this one because you can both draw a resonance structure. It's the same sort of thing as the one shown on the right. And also there's the inductive effects of these chlorines. And so since this is the most stable structure, the one in the middle, um, the corresponding acid is the most acidic. This is the least stable conjugate base, and so this is the least acidic um, of the structures shown. So in the case of number 8, you're given a structure like this. That's actually in the previous problem, but when you see it in the context, the first two, in the context of number 8, it doesn't show the protons in the middle. Nonetheless, one of those is the ones that is removed. There's three ways to know that. One way is, that you remembered it from the previous problem, number 7. The second is that you use the pKa table, which shows that the pKa of this middle carbon is around 8.9, um, and and less for the structure on the left because of that fluorine. And the third is to actually draw the resonance structures to show that the resulting conjugate base, when you deprotonate at this middle position, is the most stable conjugate base that's formed. And so what you need to do is this is an example of what the second structure and its conjugate base would look like. And then you need to be able to draw the two resonance structures of that to show that that's going to be a more stable conjugate base than, for instance, the structure all the way over to the right, where again it turns out that it's the protons that are adjacent to that carbonyl that are the most acidic. So what I was looking for is the correct conjugate base, and then the resonance structures that you can draw that show that this one and this one, the two on the left, have more resonance structures that you can draw and are therefore more stable conjugate bases, which means that these acids, these starting materials, are more acidic than the one furthest to the right. And of course, for the middle here, there's no resonance that you can draw, structures that you can draw at all. And in fact, there's no electronegative elements or anything like that. So it's the least acidic. I think you had the order right in the problem, but the conjugate bases and the resonance structures were missing. So if you have further questions, let me know. I'm happy to follow up if needed. Thanks.